In the next two segments, we'll continue our discussion of the Code Worlds class, looking at its use of exceptions. And in this segment, we'll do a fast review of Java exceptions, and in the next one, we'll look at exception handling as an example of object-oriented design. Now, both main and get-init-config, as you can see in the code here, use Java exceptions. And Java exceptions are a tour de force of elaborate inheritance hierarchies, and so they're worthy of a bit of study from an object-oriented perspective. Now, first, I think what we'll do is a fast review of Java exception handling. This is prerequisite background for the class, but it may not be fresh in mind. If you already understand Java exceptions thoroughly, you can just skim this review. Just by the way, in the code, we're talking about such things as try here in the main, and catch down here, and statements like throw right there. That's what we'll be reviewing. Okay. Now, first of all, why do we have exception handling in the first place in Java and in other languages? Exceptions, or error conditions, like a failure to open a file or a badly formatted or missing input, dropped network connections, all that sort of stuff, those routinely happen, especially during input-output operations, and they must be handled by some kind of error messaging perhaps, or attempts to retry the bad operation. But just sticking an if check at the point where the exception occurs and handling it there won't work for several reasons. Okay? First, the same exception in a method may be handled differently within the same program depending on what methods called the one that encountered the exception. In one case, a missing file name may need one kind of handling, in another case, it may need another. Number two here, exceptions are often detected by library methods. So, for instance, when scanner's nextInt method encounters a non-integer input, there's an exception. And the library method may be used in thousands of different programs. Obviously, nextInt is used in lots of places, each with different policies for exception handling. Third, exceptions often mean that the rest of the code in which they occur cannot be completed and must be skipped. And then fourth, the same exception might happen at many different points in the code. Handling it by repeating the same handling code at each point that it occurs is not dry, does not avoid repeating yourself, and has the usual errors for non-dry code. For instance, a failure to modify all instances of the code when changing the error handling. Now, the best solution for all these issues is to concentrate exception handling code in a few strategic top-level methods of the program, often in the main method, for instance, like we're doing here in the main of Code Worlds. Then the methods that hit exceptions pass back exception information to the exception handling code in their higher level callers. This is exactly what Java's exception handling enables, and is why all modern languages have something similar. Now, Java exception handling comes in two parts. The first is a try-catch structure, like the one here that comprises most of the code in main. Such a block starts with try, right up there, followed by a brace enclosed block of code, which runs down to here, and is termed a try block. This is code that might hit exceptions when it runs. Often the try block is an entire function body, but it can be a smaller bit of code too. After the try block are one or more catch blocks. As you can see down here, got a couple of them. These look a bit like functions, with catch followed by a single parameter that describes an exception, and then a braced block of code below it to handle the exception, for instance, by printing an error message. We actually have a logger call here, but I have a commented out print message that would be an alternative possibility. And then finally, after the catch blocks, may optionally appear a finally block. We don't have one in main, but we do have here in a similar try-catch block in init config, which has try there. And then when we look down, we have a catch, and then this finally block after the catch. And this contains code that must be done regardless of any exceptions, usually such housekeeping as closing open files or closing scanners, in as a scanner, as in the getInit config finally block here. Now the partner to a try-catch structure is the throw statement, like this one here in main. A throw statement is kind of like a supercharged break. It jumps straight to a catch block, passing it the object after the throw. And a throw always has as its argument some object, usually dynamically allocated. It skips over all the remaining code in the try block when it does this. Now, that last point is important to remember. It's tempting to think that the code following the throw will get executed since there's no else. But it's all skipped by the throw, as if the throw were a break statement. So from here, we go straight down to the catch blocks. A throw jumps to the first catch block having a parameter matching the object thrown. So our example throw statement jumps to the catch block that has a CWS exception parameter. Only objects of certain classes, generally termed exception classes, may be thrown or caught. And these classes are distinguished by being subclasses of java.lang.throwable, and almost always also subclasses of throwables subclass Java lang exception. There are hundreds of exception classes throughout the Java libraries, each designating a different kind of exception. And each catch block can be designed to handle a specific exception by specifying the relevant exception class as its parameter. The member data of exception classes always includes at least a string describing the error, passed as its constructor parameter, in fact, as in our example throw statement up here, where we had a usage string as the parameter. That message string may be retrieved via the method getMessage, like that, and that's typically done in a catch block, as in our example, to print out what went wrong. And so we come now to our first in-lecture question. Look at the Java docs for the package java.util. Java.util. You'll find all the exception classes listed together in the class summary to the lower left. Roughly how many exception classes are there in this important package? And which ones are potentially thrown by java.util.scanner's nextInt method, which we'll be looking at in a bit. You check the nextInt documentation for that. So hopefully you gave that a bit of thought and came up with some answers, and here's my answer. First of all, looking down at the exceptions, this is java.util we're looking at here, and the lower left panel here has all the classes, but as you can see, there are also exceptions down there, starting here, and there are quite a number of them. Something on the order of about a dozen or 20 or so, I believe, and that's about one for every 2 normal classes. And 3 of them might be thrown by scanner nextInt. If we go down and look at the docs here, there's some preliminary explanation. So there is nextInt, and you can see that it lists 3 possible things that it throws, and those are input mismatch exception, no such element exception, and illegal state exception. Although the latter one, the illegal state exception, is from a different package actually than java.util. Okay, importantly, and this is something you really be sure to understand about exceptions, if an exception is thrown in a called method for which there is no catch block, then the exception is thrown back to the caller of the method. If the caller can't handle the exception, then the buck gets passed to the next caller back, and so on all the way up the call chain to main, whereupon the buck either stops with a suitable main catch block, or the program stops altogether with a runtime fault and a stack trace showing the exception. And here's a diagram to help visualize this. Say function f1 calls f2 from within a try block that has a catch for exception type botch. And then f2 in turn calls f3 within a try block with a catch for a type mistake. And finally, f3 throws a botch object with an appropriate error message, but f3 has no catch block for botches, only for problems, evidently. So the exception goes back to f2, which also lacks a catch block for botches. So the exception finally goes all the way back to f1, which does have an appropriate catch block. And the big blue arrow here obviously shows that jump. And be sure you understand, neither the more yak code in f3, nor the more blah code in f2, nor the more yada code in f1 will be executed. That throw statement is a grand jump all the way back out of the call sequence straight to the nearest available catch block. So exceptions within a try block may arise not only from immediate throw statements in the try block, but from any method directly or indirectly called from the try block. So with that information in hand, let's look more closely at the main try block. Many different exception classes might be thrown by the code in this try block. Some are obvious, like CWS exception there, but others are only thrown indirectly by methods called from the try block. And by the way, not all of them are caught by the main catch blocks, at least not directly. We'll talk more about that in the next segment. So what follows is a series of questions asking you to track where each exception in the main try block might come from. And for each exception, tell all points from which it might originate. Don't list origination points unless the exception would actually reach main. You'll need to consider both the main try block and any methods called by it. And Java docs for the library methods, remember, list all possible thrown exceptions for each method, for each library method. So, question 2. First, CWS exception. Where can it come from? And after some thought, well, one obvious place is right here, of course. But be sure you also saw the ones that could reach it through get init config. We've got one there, and another one there, and yet another one here. And all three of those will reach main if thrown because there's no catch block for CWS exceptions in get init config. So scrolling back down then to the main try block for question 3 then. What about file not found exception and security exception? And a bit of research in the Java docs answering that question now will show that file not found exception and security exception are thrown from the constructor of a file input stream. File not found exception, security exception, right down here. And those therefore could arise from this new file input stream call in the main try block. Okay, and next up, what about no such element exception and illegal state exception? So if you've had some time to think about that, then I hope that you looked over at the scanner class and noted, as we pointed out earlier, in fact, that the nextInt method, and indeed the next just about anything method, is able to throw input mismatch exception, no such element exception, and illegal state exception, in fact. And that's true for methods like nextInt or nextDouble up here, or any of the others. But do note also that no such element exceptions thrown in get in get init config here, which we would have from possibly the next calls and so forth, are caught there, and therefore will not make it to main, not from get init config. Now, from this little exercise, you can see that it's easy to be surprised by exceptions thrown from called methods. To make exceptions somewhat less surprising, every method that might throw an exception back to its caller must announce this fact with a throws clause after the function header, listing all exceptions that might erupt out of the method when called. And you can see an example up here in getInit config, where it has several throws of CWS exception that are not handled by any catch block in get config and thus would be thrown back to the caller. And the throws CWS exception in the getInit config header announces this. And note, by the way, this is not an optional documentation standard, as it is in some languages. The Java compiler requires these announcements via what is sometimes termed the catch or announce rule. You catch your exceptions, or you announce to your caller that it had better be ready to do so. So, what about, say, illegal state exception, which might be thrown from scanner calls in getInit config as we just discussed? Why don't we have to announce it in getInit config? Well, we'll explain that in the next segment, where we'll look at how inheritance relates to the design of exception classes, including determining which ones must be announced, and also how to make our own exception classes.